all for joining. Attendees are still climbing, but we have to start somewhere. So let's make a start now. So first of all, welcome to the ArtFlash Ratings, Crossovers and Grey Areas webinars. This is the first of our Power Hour series of webinars. The second one will run in about a month's time. More details on that at the very end of this webinar. So as with all our webinars that we've been doing since 2020, anyone that registers for the webinar will get a full recording of the webinar afterwards, and I believe a slide deck as well. So if you need to share it with Teams, you can do, or if you want to register and you can't actually make it at the time, people's diaries change, we get that. At least you get the recording later on to listen to the information given. And but yeah, so thank you very much for joining. We'll try and make this brief and keep it going. So thank you very much. Let's start. So first thing today, we're going to talk about our learning outcomes from today's webinar. So first thing is understanding the key ArtFlash ratings. So the differentiate between ELIM, ATBV, and EBT. Not everyone on the call, our conscious it's a global call, not everyone will be familiar with ELIM. We'll talk about it in due course. Know why ELIM is not recommended. So that might be a bit of a surprise to some people on the call. So we're going to understand the limitations and risks of using ELIM in the PP selection. And then leverage ATPV and EBT. So we're going to learn how ATPV, EBT can work to your advantage. And distinguish between category and class. So we're going to discuss the difference between the PP categories and also classes of ArtFlash protection. And then we're going to compare class and cal ratings, look at whether there's any direct comparison between class and cal per centimetre square ratings. So first thing we're going to talk about is breaking down the three, which is ATPV, EBT, and ELIM, and then the two, which is class 1 and class 2. So first of all is breaking down the three. We have ATPV, which is arc thermal performance value. So often people will talk about a cal rating being an ATPV cal rating, or now in UK and Europe, they talk about it being an ELIM cal rating. But obviously, as you can see on the screen here, there's actually 3 cal ratings you get. So ATPV is looking at the actual thermal performance of the garment itself, or the fabric, you should say. So the garment and fabric tests are different. So fabric test will actually give us the actual rating of the fabric. Garment test we'll talk about later is a different thing. So ATPV, arc thermal performance value, how does the fabric perform in an arc, and what protection will it give you from the onset? And it's a 50% probability of the onset of second-degree burns. EBT is energy breakthrough, energy break open threshold. And this is the 50% probability of the actual break open of the fabric itself. So fabric behave in different ways, which we'll talk about through this session now. But EBT is where the fabric is broken open before it's generally reached the ATPV limit, but we're going to discuss a bit more on that in detail. And ELIM is basically designed to eliminate ArtFlash burn. So rather than being the 50% probability of the onset secondary burn or the 50% probability of a break open, it's looking and saying, what can we achieve? 0 break open, 0 burns. Okay, so they're the 3 which have a cal rating attached to those. And here then is a video. Any of you who've been in my ArtFlash awareness sessions that I've done at your premises will probably seen this video a few times. It's a video we did a short while back, and it's an open arc video. So this is actually testing garments rather than fabrics, but it should show you what an open arc looks like, and to give you a bit of an understanding as well. So we're talking about ArtFlash PPE today. The reason we're talking about that is ArtFlash PPE. It is the last line of defense. However, it is a crucial part if you're working on only a live electricity and there is a chance of exposure to ArtFlash, then it's better to have some ArtFlash PPE on than have nothing at all. As you'll see in the video here now. So the video you might be able to see in between the 2 garments is there is two conductors here, and in between is a fuse wire, and there are sensors here and here either side of the actual mannequins themselves. So you'll see the ArtFlash now. Okay, so the ArtFlash goes across a 30 centimeter gap between the 2 conductors. So as you can see on the left hand side, the garment is charred. It's remained intact. It's not broken open, and would have protected the wearer. On the right hand side, not the case. And to give you a bit of an idea, understanding of this as well, or to get into context about what we're talking about now, is if you are wearing a garment which doesn't actually meet the arc rating that you are expecting within a particular unit of equipment. So say, for example, the equipment is rated at 14 cal and you're wearing 12 cal, okay, you may be sore as a result of the arc flash. But if you're wearing the garments on the right hand side, which go up in flames, no no amount of arc flash energy will give you the burns that fire gives you. So prolonged heat, exposure to heat is far, far worse than the arc flash incident itself, which is obviously over and done in a fraction of seconds. Sorry, excuse me for that bit of hay fever and getting my throat. So hopefully we'll be able to continue. So here in the screen you see in front of you, there's normally the first parts of the graph that we look at when we get an arc flash test report for fabrics. So when we send fabrics off to the arc flash test houses, so there's one in Europe, in Spain, and one in Canada, at Kinetrix lab there. And first thing they'll produce is a report, and on that report, this is one of the first things that we look at. So there's all the technical details before that I'll look at, in terms of weight of fabrics, weights before wash, after wash, etc. But this is the main thing that actually gives me the results of what I want to look at in the first instance. So this graph shows you, just to break it down, make it simple for everyone. On the left-hand side, you've got probability of an arc flash or burn, should I say. So at the bottom is 0% probability of a burn, and at the top is 100% probability of burn. So in the burn instance, when they are checking what actually happens in the arc flash, it is showing that we've either got a burn or there's no burn. So that's why you've got a 0% or 100%. So at the bottom there, starting off here, you have an arc rating at 5.9-ish roughly, okay, but no burn. Then you've got 6.9, 7, etc. all the way through here of no burn. And then once a burn, you've got up here, you've got like 8 cal, and then up through to probably 9.7 cal, and they've burnt. But obviously you've got also here an 8.9, which didn't burn. Okay, so in this here, they will then take the top 3 points, arc flash points, where there was no burn. So then obviously this is a mix zone here where you've got a mixture of burn and no burn. They would take the top 3 where there is no mix zone, and then they would give you an average of those and say at this point you aren't going to get burnt. Okay, so that's what they're eating from. But also in the bottom corner here, you then see if it's a European arc test, we get these 3 figures, generally speaking. So you have an ATPV, EBT, and an ELIM. And obviously, if you're testing to the North American standard, ASTM F1959, you just get the ATPV and EBT, and you don't get an ELIM rating. Okay, so this is the detail we get on a report itself. So breaking down the 2, so class 1 and class 2 closed box arc. So this, what you saw before was an open arc. So the arc is in open air between 2 conductors, again 30 centimeters apart. On a closed box arc, this is an arc inside a box, so it's classed as an ejected arc. You can only go out the open side of the box, which is one open side. Inside, the conductors are a lot more close together. These are often linked to, in the real world, to cutout enclosures, link enclosures, etc. So it's in an enclosed area, 2 conductors, 3 centimeters apart rather than 30, and then but the voltage rating stays the same. The time for the arc flash remains the same at 0.5 seconds. But what we do change is class 1 has a 4,000 amp short circuit current. So it's 4,000 amp short circuit current on an LV circuit of a 0.5 second arc. And then class 2 is a 7,000 amp. In these arc tests, there is no grey area. There is no, it's a good class 1, or it's a 1.5, or a 1.5, 1.6, 1.7. It's a class 1, or it's not. So if it meets a class 1 arc, it will get a class 1 arc certification for that fabric. If it's class 2 arc, it gets a class 2 certification for that fabric. If it fails to meet a class 2 arc, it's still a class 1 arc, even though the fabric might have just missed out on class 2 arc by a hair's breadth. It's still a class 1 arc fabric, not a class 2 arc fabric. So it's pretty limited in its application. We use it purely for complying with area companies that would want to have class 1 or class 2 requirements in their fabrics, but also as an actual garment test. It's a more powerful, concentrated arc, should I say, So we do use it in the garment tests as well. So all our garments are certified to Class 1 or Class 2 and ATPV, EBT or ELIM thing. Next slide. Done. So is there any questions that have arisen during this session that people want to put forward?
I've made a note here, Anthony. If you want me to quickly go through them now.
Yes, go for it, Ben, please.
Yeah, so from Bob Eka, so sorry, Bob, if I've pronounced that wrong. So what is the best Art Flash clothing to wear and when?
The best outfit clothing to wear and when?
Yeah, we could be a little biased with this one, but
Yeah, so obviously, yeah, we can wear Strata, Alpha Protection. This is the best to wear from SKANWEAR. But ultimately speaking, yeah, it would depend on what your arc rating is, which we can discuss in more detail, particularly if you then need to layer up, which we'll then talk about the EBT, ATPV ratings and how that works. But yes, there's no actual particular art for PPE which is best to wear. But obviously, if you're looking for a brand, well, hello. But this is not commercial today. So, but if you want to have a chat afterwards, feel free to reach out to us. I noticed there's a question as well, Ben. Is that right? Or two
yeah,
questions?
there's two questions now. Are there any standards for safety footwear from an Art Flash perspective? If not, is it true that boots with leather uppers are recommended?
Yeah. So the only ARC standards for footwear are the ASTM ARC standards. There is no European ARC standard footwear as yet. And but definitely, if you don't have an ARC rated footwear, definitely wearing leather uppers is obviously preferred. And what I was going far to say as well is knowing the equipment that you're working on. So something I delve into in a bit more detail with the alpha sessions that we do with clients is if, for example, you are working on floor-mounted breakers, for example, then there's a high chance that the arc will come out along the floor and up. But obviously, if you're working on equipment where it's more at chest height, the chance of the arc coming out the cubicle and down to your feet is pretty rare. So yeah, non-melting or leather is an ideal situation for that. If that's what you're
Have
looking
we
for.
got time for three more questions and then
Yeah,
we
go
can
for it. Yeah,
move on?
yeah, that's
Yeah,
good, good.
so another one from John Connolly. When selecting PPE, are you going on the safe side by selecting class 2 in all areas?
So class 2, you might be over-specking it in some areas, and you may be under-specking it in other areas. So we tend not to refer to class 1 and class 2 because they have the limitations, and we would generally refer to cal ratings. However, I know that some operators do operate class 1 and class 2, and in Europe, we have a lot of companies in Switzerland and Germany, particularly, where they have local regulations that dictate that it should be class 1 or class 2 out garments that are worn. So yeah, to state a class 2 garment as the standard, as a safe bet, you may be overcooking on some areas, but then other areas you may need more protection than just a class 2 arc. And we'll talk about that in due course.
Awesome.
Is the next one, Ben?
Just two more, and then Austin, we'll save yours for the next little forum that we've got going on shortly. So this one's from Darren. So is there a way to compare class 1 and class 2 to cal/centimeter squared?
Brilliant. Be my guest. So thanks for that question, Darren. In about 4 or 5 slides time, I think it will be roughly. I'm asking very good. We'll jump onto that session to discuss that. So thank you for raising the question.
Excellent. I'll
But
close that
so
off.
we'll crack on then. Thanks for that. Thank you very much.
Thank you. Let's keep going.
Okay, one off there. So okay, so now we're going to compare the ratings and clarify misconceptions. First of all, ATPV versus EBT, which is better. So I hear people say sometimes, I don't want an EBT rating, I want an ATPV rating. Well, do you know what? Sometimes that garment hasn't got an ATPV rating because you've got to have an EBT rating. So the lowest calorie value between ATPV and EBT is the one that's published. So that is the same for the ASTM standard and also for the 61482-1-1 standard. So both of those standards are stipulating that when you advertise an ATPV or an EBT, it's got to be advertised as the lowest of those two values. And then obviously in the European one, you've also got to advertise the ELIM rating as well. So ELIMs in the European standard is a given. You've got to do that regardless. And ATPV, EBT are optional, but again, the lowest. And obviously in the ASTM standard in the USA is ATPV or EBT and the lowest of those two. So you're only showing the lowest one that's published. So I'm going to show you a bit of a graph here on the side. So we do as a business, we do a lot of dual layer artfast testing. So we test garments to give clients the ability and understanding that they can then quite easily refer to that as part of a layering process to achieve a higher arc rating by using the left-hand side column for their base layer garments, and then the right-hand top column as the outer garments. So I'm going to pick on the top left box here. So undergarment SFX 101 men's t-shirts, and then coupled with an SFX 404 fleece is achieving 39 cal, 80 BV, and a 34 cal elim. Obviously, that's PPE category 3. We're not quite in category 4 PPE at that point. Okay. And we have a new material, which you'll see highlighted on this SFV 101 men's t-shirt, new material. Okay. So in this situation, the fleece itself is is a bit of a unique one. It's both an ATPV and an EBT at 11 cal. So both of those at 11 cal. So it's a funny fabric, but it's a good cal rating for the fabric it is. So when we do the first one, the top one, SFX 101 men's t-shirt. So this one here. Okay, this fabric here is an 11 cal 80 BV base layer. Okay, this is achieving then underneath the fleece a 39 cal rating. When we go to a t-shirt, this is a 9.3 cal EBT, so it's energy breakthrough. You've then only got 35 cal. Okay, when we move to soft shell jackets, same t-shirt but different outer. So inner is still at 39 kV, sorry, 39 cal. So bearing in mind the soft shell is a 28 cal garment, fleece is 11 cal garment. So 11 cal and 11 cal, we're getting 39 cal. 11 cal under and a 28 cal outer, we're getting 39 cal, same again. When we change to the new fabric, which again is a lower cal rating but EBT, when we compare the two together, the fleece and the t-shirt is 35 cal, so we get a drop of 4 cal. But when we test the t-shirt underneath the soft shell, we then get a 47 cal. So in this one here, both the soft shell and the t-shirt in this case are both EBT garments. So when they are both EBT, you can see we've actually got a far, far higher arc rating combining the two layers of EBT. So it depends on how the rating performs of the fabric, and then when you layer them up, how they're layered up as to how well Artflash extra layer works when combined with a layer in between. So keep your mind open on ATPV and EBT. Obviously, by all means, you can refer to our chart, which shows you the layered options we have available. I think we've tested virtually every single one of our 2-layer options available to help you out on that. So you can quite easily get access to that. It's in our catalogs, and I believe it might be online as well. So that'll help you with that. We're then going to move on to elim doesn't work. So this is a big question. I get a question a lot in the UK, particularly in Europe, about elim. People saying elim is the best arc rating, and this is what everyone should be working by. Why are you still mentioning ATPV? Why do you still mention EBT? Well, we put elim in our garments because obviously it's required by European law to put elim in our garments. But however, we also mark our garments as ATPV and EBT. And on all our garments, on the outside of the garment, the actual arc rating that is on the outside of the garment is an ATPV or an EBT rating, not an elim rating. The elim rating is found on the inside, which is a compulsory unified label on the inside. But on the outside, it's the rating that we sell that garment as, which is the 50% probability of either thermal performance value or the breakthrough. So we're going to drop a poll now. So do you think elim is an accurate form of arc flash measurement? So if you can pop the poll on the screen, Ben, if that's working. And then, so simple question there. Do you think elim is an accurate form measurement? So single choice, select either yes or no. Let's see the results come through. So you can click on the screen there, it should be able to.
I'll give it another 10 seconds, Anthony.
Yep, no problem at all.
That'll be interesting. Another.
Anyone that knows me will know how I would vote. And
Okay, 5, 4, 3, 2,
grand
1.
reveal. Wow. So we've got 41% think it is an accurate form and 59% don't think it's an accurate form. Well, congratulations, 59%. You're on my team. So yeah, if you can close that poll down then, Ben, we'll move on to the Next slide. Sorry, my cursor's a bit slow. Okay, so busting the EN rating. So as I said before, EN rating is only applicable in Europe with the EN 61482-1-1 or the IEC 61482-1-1, and it is not used in the ASTM 1959 or ASTM 1506 complete tests. So the question is, why have we got this in Europe? So the European original ARC test everyone did, excuse me, was a closed box ARC test. So I mentioned before, closed box ARC test is either class 1 or it's class 2, and always is either pass or it's a fail. There's no other rating for that. So there's no probability. It's very defined. But at the same time, the art flash is also very defined. You have a box with conductors inside the box. You have a fabric which is 30 centimeters outside the box. So the art flash is obviously only generated between a small gap. It's ejected out of the box to the fabric that's waiting to receive the art flash. So the art flash is very, very centered on the garment itself. So when we look at the actual possibilities or probabilities of burn, etc., it's a really, really clear indication that there's no really probability. It either burns or it doesn't burn. So if it burns or it breaks open, it failed. If it doesn't, it gets the class 1 or the class 2 rating, whatever it is. So it might, as I said before, it might be a fantastic fabric, easily achieve class 1. It goes for a class 2 arc test, it breaks open, or it goes through a class 2 arc test and it burns, then it's a write-off, even though it might only be a very, very slim way away from class 2. There's no middle ground, and it reverts back to being a class 1 article. Okay. So if you imagine before, there was no probability, it was really clear, pass or fail. And then all of a sudden, we then get this 50% probability with the ASTM F959 test, which is checking what the probability is. And there is a probability with the art flash ratings of ASTM F959 for a reason. Okay. So we talked about, is it like a form of measurement? No, it's not. So anyone that voted no, you're correct. Anyone that voted yes, I'll agree with you 5%, I would say. But in the main, I don't agree with you. And so the reason behind why I don't agree with you is if, for example, you said, so we had raised a question before, what art flash PPE would you give people? And then you had the question of, would you give people class 2 as a standard article, for example? So if, for example, you have an art flash rating and this says that you need to have 40 cal, okay, and you have to have a 40 cal elim garment, the 40 cal elim garment will probably weigh twice the weight of a 40 cal ATPV garment. Okay. Open arc is really, really unpredictable. We'll move on to it in a slide or two. So because of its unpredictability, elim is like trying to say it's really predictable. You can really guarantee it, but it isn't. So moving on to the next slide. So this fabric here, so this is the same test of a fabric. So you've got the 50% probability of a secondary burn, 50% probability of break open. This is on the same fabric, okay? So this fabric is rated at 11 cal. So you round up when it's over 10.5. So it's 10.73. It's the low over 2. So this fabric automatically is an 11 cal fabric. This fabric started off as a 12 cal fabric. We marketed this product as a 12 cal fabric, and then it was retested as part of the testing criteria. So for everyone on the call, European ARC tests have to be done as a maximum every 5 years. ASTM tests only are ever repeated when there is a significant change. So if you've got an ASTM rating on a fabric and no European rating on a fabric, check when the rating was of that fabric because it might be quite old and things will change. But in the European test, it was redone again because obviously it was old. So originally it was 12 cal EBT. It was redone again and it came out 11 cal EBT. We had a lot of clients who were buying that polo shirt because they wanted a 12 cal EBT polo shirt. Okay. So all of a sudden we've got that polo shirt as 11 cal. Okay. So we then tested that again. Okay. And this time round, we got an ATPV of 15.6 and an EBT of 13.8, which then means that the EBT rating is what gets published, and that is a 14 cal elim garment, EBT garment. Okay, so in that garment alone, the fabric weight was the same on initial receival, When it was washed, it was still the same weight as the previous test. The test was conducted exactly the same, but we've got a 2 cal, 3 cal jump in protection level of the polo shirt. Okay. So if we had elim, the elim is the elim on the day that fabric was tested. If you then tested that fabric twice on the same day, you would get a different elim rating every single time. So every single time we test a fabric, we get a different arc rating virtually every single time. Some fabrics are more stable than others. Some fabrics move a lot, particularly knitted fabrics, they move a lot. So it's harder to actually guarantee that this is the actual rating. So when there's an elim rating, the elim rating is the elim rating on the day of that particular test. The elim rating isn't guaranteed for every single time you wear that garment. However, conversely, ATPV or EBT values that are given are a 50% probability. So it's a 50% probability that they will protect you in the event of an arc. And the 50% probability is because of this next slide here. So after you get those graphs that we just shown on the previous slide, this then here is the next part that I look at. So this tells me a few things. First of all, it's going to tell me the actual test. So you'll see 1, A, B, and C. So A, B, and C are the 3 different panels within the arc test. Test 1 is the test that was carried out. 2, A, B, and C is the 3 panels that were tested on the second one. Okay, so in there, you'll see that the first one, 1A, time in milliseconds is 213. The first test, 212.4 for the next one, and so forth. Okay, then you have the cycles. We're talking at 50 hertz here. Then you have the cal rating. So this is the actual cal rating or energy that was received on the sensors that are adjacent to that test piece. Then we're going to jump and leap over to the burn, and the N says it's no burn, and the break open says it's no burn. So first of all, to give you an idea, in one arc test, if you look at line 3A, B, and C, so it's the one with the red circle round, this is one arc, and it generated one energy impact at 12.2, one at 13.8, and one at 16. Okay, so this is all the same arc. Okay, and then you'll see over on the left here. So at 16, we got a break open. 13.8, we got a break open. 12.2, we had no break open, but at no point did any of those burn. Okay, next one down, test number 4, we have a 15.9 cal, a 14.1, and a 15.6. But you'll see at the 15.6, there was no burn, but at 14.1 and 15.9, it did burn, and it broke open all 3. However, when you look at the line above, at 16, there was no burn, okay? And at 13.8, sorry, at 12, there was obviously no break open. Further on down here, we have 6, A and B and C. We have 15.6, 17.3. So again, a big jump, 14.8, 17.3. And at the highest arc rating, 17.3, there was no burn. Okay, so this is the unpredictability of an arc. An open arc test is a really, really unpredictable test. And every time we test fabrics, we can test them on simultaneous days and we will get different results out of the same batch of fabric. And when fabric is produced, it's also produced within tolerances of weight. So each of those fabric weight tolerances, again, will also again lead to an unpredictability. So the 50% probability is what we always advertise because of we know the probability that goes A, into the arc flash testing itself, and B, into the actual production of the fabric itself. So we're looking at the 50% probability. Plus, when we test fabric, we're testing fabric directly on the actual heat sensor at the back, which is picking up how much heat comes through the fabric itself. Unless you're wearing underwear, no garment you wear will be so tight to your skin that there is no air gap. When we do dual air tests, there's air gaps, which is why we often see a spike in the actual arc flash ratings. So where you might say, I've got a 10 cal garment and a 10 cal garment, and I'll achieve 20 cal, because you've got an air gap in there, often you'll end up with a higher cal rating. Obviously, not always. So because of that 50% probability, that rings true. A, from the chart you see here now, and the previous charts you see on the same fabric, we get different arc ratings. So this is where we don't believe elim is a valid point. Plus, when you move up the scale in terms of protection, it also means you more than double the weight of the garments. So if you have a 12 cal Elim garment, that would be a lot heavier than a 12 cal ATPV garment. And then when you get to 40 cal, it's like near double the weight. So Elim is really restrictive, really limiting. ATPV or ABT is the best option to get a realistic understanding of the protection of the fabric itself. I'm just going to jump now to the next one, which is some more questions if anyone has some.
I've got plenty, Anthony, some from the previous as well. So I'm going to go back to some of the previous ones from the chat earlier.
Go for it.
So this one's from Marcus. So does EBT apply to outer glove protectors?
So outer glove protectors are only tested to the ASTM standard, and these will always be ATPV or EBT. So there's no European test for outer glove protectors, hence the reason there's no ELIM on those. And most outer glove protectors we've seen, if they're a leather-based product, generally speaking, they have an ATPV rather than EBT because they don't break over very easily.
Excellent, thank you. So this one's for Austin, the next one. How do we safely determine the appropriate level of PPE for operating equipment with high incident energy behind a dead front? For example, 100 cals behind a dead front or anything over 40 cal.
Just read that question again, man, so I can
Yeah.
get the gist of it.
Yeah. So how do we safely determine the appropriate level of PPE for operating equipment with high incident energy behind a dead front? For example, 100 cals behind dead front or anything over 40 cal.
I probably need to enter into more of a discussion on that regarding what you're meaning there. Is the actual question on this thing? Is it?
It's in the chat if you just scroll a little
Oh, in
bit
the
higher
chat, two
up.
seconds then.
Yeah.
Um,
Just from Austin at 3:14.
14. Yeah. How do we safely determine the appropriate level? So if you've done an art flash study, that would give you the art flash rating for the particular equipment that you're working with. And obviously, if it's a really high arc rating, I would question, can you do something within your engineering controls to actually bring the art flash rating down? Or can you do anything within the hierarchy controls to bring the arc flash rating down or reduce the exposure to the arc flash? I know there are suits out there that are 100 cals plus, etc. Would I advocate them? Not necessarily, but if you really need to use that and that's your last practical line of resort, then I would do so. But yeah, high arc rated articles are readily available. Um, but ultimately speaking, yes, doing the actual alpha study, making sure it's correct, making sure your fault levels are correct first before the alpha study is carried out. And then if you can alter the fault currents, then great, do that, alter relay times. That will make a massive difference to the actual fault current. And obviously then hence reduce the alpha risk of the equipment itself. I trust that helps, but feel free to drop me a line if you want to take that offline and discuss it in a bit more detail. That's okay.
Yeah. How many questions we got time for, Anthony, before we keep going?
Yeah, a couple more. Yep.
Yeah, so this one's from Jack. What would the PP recommendations be if sites do not wish to conduct art flash assessments so the rating is not known?
Okay, so if we get this a lot of times. So clients of all of a site, they're not running out flash instant energy results on that site. We would generally always point people in the direction of NFPA 70E, table 130.7C, which basically sets out various different scenarios and the likely art flash ratings or protection level you would need to wear for those instances. Or a better one will be CSA Z462, which is a Canadian art flash standard. They kind of mirror each other, the NFPA 70E and the CSA Z462, but the CSA Z462 tables are far better. You can get those tables or those actual documents anywhere online. I believe Amazon sells both CSA documents and the NFPA documents, or you can buy them off the NFPA or the CSA websites. But definitely speaking, if you haven't got an art flash study done and you want to make sure you're wearing the right protection, definitely hit up those two documents or give us a shout and we'll look into it for you as well from my past experience and guide you in the right direction. So feel free to drop us a line and we'll be in touch on that point if
Good,
that's okay.
good stuff. Should we do two more and then keep going and leave the
Yep,
rest of the questions till the end?
go for
So
it.
this next one's from one of our own, from Adrian. So why do we have EBT, APT, ATPV, sorry, and ELIM? Why do we not just have the one rating?
Yeah, so the ATPV is obviously it's telling you the art of film performance value. When we test garments or test fabrics, should I say, sometimes fabrics might be a bit more weaker in terms of their actual protection, from break open, but their thermal qualities are better. So often when we see an EBT rating, it is less than an ATPV. So it actually means it's broken open before it actually reaches burn limit. So we have to have the two standards in there, because otherwise, if it only had the ATPV rating, it would then be higher than the EBT, which would then be a risk. Or if we only had ATPV, but the fabric did break open, then you'd have an issue with the fabric being advertised at a protection level that's higher than the actual garment could possibly be exposed to.
Thank you,
So,
Anthony. Just the last one, then I will keep moving till the next Q&A. So this is from N. Ross. So, but what a wearer is interested in is not getting burnt. Knowing the level of knowing the level at which there's a 50% chance of getting burnt doesn't help with this. What are your
yeah,
thoughts on
so
this one?
good question, and I come to completely get where you're coming from. So in an art flash itself, so we talked about when we test fabrics, we're testing them with no air gaps. So this is literally like it's right next to your skin. It's also in the direct way of the art flash itself with the open arc. And the 50% probability is because there's a high chance that this is a static fabric in a static arc situation in real life. So we talk about applying a 2-second rule to art flash instant energy results. You see the art flash and you move away and you step back. In the arc test, it's fixed, but a fixed distance from the actual conductor itself. So in real life, the 50% probability does play out in terms that you're more likely to have an air gap. Air is a brilliant insulator for art protection. We know multiple situations where people have had art flashes wearing art flash PPE. The instant energy has been way over the actual PPE itself, and they come away completely unburnt. So the 50% probability is in a lab. Everything is fixed. Everything is set. In real life, you're likely to be further away from the arc, or you're likely to have more air gaps between your clothing and the arc, or be able to step back as the arc generates, which obviously reduces your risk. And also, then if you're looking at Ealing, there would also be a practical situation particularly if you're wearing day wear. So when we term day wear, we term that as shirts, polos, t-shirts, pants, trousers, etc. As your standard day wear. If you had, for example, a 12 cal minimum as a day wear, and you decide to change that to 12 cal Ealing, when you're working in a hot environment, for example, you then may struggle with a 12 cal Ealing, whereby you actually might feel quite comfortable with a 12 cal ATPV or EBT fabric. So it's understanding what the risk is, what extent that risk is, what the working conditions are, what the environment is, because it's no point having a whole lot of PPE that's too heavy for people to wear, and then people don't wear it because it's not practical to wear it, and then find that they're not wearing it, and then they're exposed to an art flash and get worse burns. And obviously, burn incidents are low, or art flash incidents are low. They are getting a bit higher, unfortunately, but they are generally lower. So you're protecting someone for a possibility rather than a eventuality. If that makes sense. So we'll move on, and if there's any more questions, we can answer those a bit further down the line.
Thank you, Anthony. Your
Okay,
presentation is ticked off.
very good. Cheers for that. Thank you. Okay, so standards, classifications, and ratings. So this is something we get
Anthony, your
across.
presentation is not showing at the minute.
Oh, it should be. No,
I'm not seeing it. Oh, I think it's maybe my side's messed up.
is it yours?
Everyone else could see it. It's just
It's saying
me.
I'm sharing it, so let's hope for the best. Okay,
Oh, yeah.
so this is something we come across a lot. People understanding, particularly in Europe, what is the difference between category ratings, NFPA 70E category ratings, or the CSA version? We've not put in there, but it is there as well. And they have a category 5 in the CSA Z42 ratings, or class 1 and class 2. So the NFPA 70E category ratings, starting at PP category 1 through to category 4, there used to be a category 0, which is basically like a cotton level of clothing. So if you were wearing cotton jeans and a cotton shirt, for example, that was classed as category 0, and then you moved to category 1, which had to be 4 cal and greater. Okay, and then so with those categories, there is no actual direct correlation with the class 1, class 2 arcs. So often we get people thinking that class 2 and category 2 are the same. They couldn't be further apart. Okay, so it's really, really keen to make sure that if someone is asking you for a class, it is definitely a class that they want, class 1 or class 2. Or if there's a category, it's actually within the NFPA category ratings, 4 cal, 8 cal, 25 cal, 40 cal. Okay. The category ratings, as I refer back to, they're centered around table 130.7 in the NFPA 70E document. Okay, where they actually will then give you various different scenarios of art flash events that may take place and the actual category of PPE to wear in those particular instances. Category 2 is often referred to as a 12 cal as well. It depends which version you're actually going by. Obviously, NFPA 70E is reissued every 3 years. So obviously, you're meant to be going by the latest current one, which I think is 2024. So in this basis, you cannot compare class and category together. If you're going to give any guidance at all, generally speaking, class 2 and category 3 are probably the closest. But if you had a class 2 garment and you need a category 3 rating, for example, you can't always guarantee that class 2 garment will protect you unless you know it's also got a cal rating with it as well. So if it's got a cal rating as well, makes it clear and simple. If it hasn't, go back to manufacturer and tell them to put a cal rating in there, or come to us, we'll have it for you. So I spoke before, so there's no correlation between the two, but where I would give you a bit of information here is, so class 2, the actual arc method for closed box arc and open arc is very, very different. So I mentioned before, open arc is very, very varied. The closed box arc is very, very static in terms of the actual results it gives. So there is more pressure to a closed box arc than there is of a similar nature within the open arc, because it's force is ejected out of the actual box itself, whereas open arc takes the path of least resistance, which is obviously through the air, so it can be anywhere within that area, sphere of the art flash generating itself. But to give you a bit of an idea, we see garments that are 15 cal, 80 PV, and class 2. But that doesn't mean to say that every 15 cal garment is class 2, because we see a lot where it isn't. So we have a sweatshirt, which is a 24 cal sweatshirt, which is also class 2 arc. It used to be a 20 cal sweatshirt, and that wasn't class 2 arc, but it's now 24 cal and it's class 2 arc. So it's around, I would say, the 15 to 25 cal mark is where you might get a crossover between a class 2 garment and the arc rating of 15 to 25 cal, roughly. So that gives you some information on that. So how these ratings are used and misused in the following areas here. So alpha studies. So alpha studies will give you a calorific rating. So if an alpha study gives you a calorific rating, I see quite a few people who will actually do an alpha study with a cal rating for that particular equipment. So they'll say this X bit of equipment is got a arc energy, instant energy of 10.5 cal. It will only give you 10.5 cal. It's not giving you 10.5 cal elim. It's not giving you ATPV. It's not giving you EBT. Okay. It's just saying the energy will be 10.5 cal. Okay. At a given distance of normally 18 inches. What you shouldn't have listed is a PPE category. So PPE categories are only to be used when it was Aaron's question was before, where we talked about when you don't have an art flash instant energy study and you need to know what the actual alpha rating is likely to be, then you refer to the NFPA 70E or the CSA Z42 tables. That will give you a category. At that point, you then use a garment within that category. Okay. But if you've got an alpha study done with a cal rating, go by the cal rating, not the category. The reason for that is if you have a garment, an art flash instant energy rating of 8.5 cal, okay, if you were to then put that into the category method, that would be 25 cal category 3. Okay. Most day wear is over 8 cal. Normally, you're layering up to achieve 25 cal. To wear 25 cal as your day wear, let's say I'd rather not wear that. There are some lighter garments in the marketplace. We're bringing new lighter articles out. Excuse me, but in the main, art flash studies should just say a cal rating. You interpret that cal rating, however you need to interpret it as. Look at where you need to do most of the work, where most of it is carried out, and look at a layering solution that fits in with your system. Don't revert to category, and obviously don't refer to class. There's no correlation between the two of those. Next one, PP selection. So understanding what the actual rating is. I mentioned before, class 2, category 2 gets mixed up a lot. If it's class 2, make sure it's class 2, and that'll have a class 2 rating in it. Don't go by the fact it might be a certain cal rating, so we'll call it class 2. It's got to have a class 2 arc rating to actually be sold or used as a class 2 garment. Likewise, if you're doing category ratings, look for the category, or the instant energy level that you need in particular clothing, use that, and then obviously refer back to what I talked about, ATPV, EBT, or if you need to layer up, take a look at our ArcFlash layering systems to see what works for you in the most practical way. At the end of the day, we're talking about saving lives, and we're saving lives by making sure also that the correct PPE is used, rather than giving people PPE that's too heavy to wear, and then risk of exhaustion, which could actually end up more fatal, particularly if you're working around live electricity, than what you would get from burn from an arc flash. So tables and risk assessment. So again, making sure that these are clear when you're doing these. Is it a cal rating? Is it a closed box arc class rating? Or is it a category method that you're using, which will give you an 8 or 25, 40, etc., within the arc rating itself that you might be using? So where ATPV, EBT, and ELIM fit into those frameworks. So as I've mentioned a few times through this is just kind of a bit of a recap on that. So you may be quite fine with using ATP fabric. You may need to layer up a lot with the particular work that you're doing. So it may be worthwhile looking at an EBT garment for either an outer or an inner, depending on the work that's being carried out and depending particularly on the climate. So we supply a lot of places which can be really, really hot, high heat. So when you're working in a high heat environment, the last thing you need is for them wearing heavy clothing with a really high arc rating. If your day-to-day tasks don't require that really heavy clothing, don't put it on there just for the sake of it. So making sure that you take a practical approach to the PPE that's worn. And obviously we do a lot of matrices with customers and clients to make sure that they have a really simple, straightforward plan of how to layer up in certain circumstances to get the right protection they need, but working from a base layer which is practical for everybody. And when I say everybody, that is literally anyone who is at a possible risk of arc flash, whether they're working directly or adjacent to live electrical equipment. They have a base level of PPE. When we see arc flash in situations happen, I mentioned before, we've had a number of clients who have had arc flashes, and what we see is, generally speaking, the clothing will sustain a higher arc rate in the actual label itself in real life scenarios. Okay, so wearing some form of arc flash clothing will always be better than trying to get to the nth degree, like Elim, of what the arc flash rating should be. So taking that really practical approach, and if you want to talk to me offline about this, I'm open to talk to anybody about this at all. It's completely free of charge. I don't charge for my time. Probably should do something. But yeah, I'll give you any advice I can do that's shared from a practical living experience of information we get from our clients, and also the actual testing world, where we're actually physically testing ourselves, our flash garments and their fabrics, and then layered combinations. So on to our last Q&A session.
Excellent.
Some more questions come through as well.
There is definitely. So last chance, folks, to get your questions in. So this first one, Anthony, is from Matt. Is arc rating affected by use around 60 hertz systems versus 50 hertz systems? HZ, I believe it says.
Yeah, that's right. That's right. So arc flash itself, obviously, the hertz will depend on how many cycles are generated within the arc itself, and then that is obviously governed by your relays in terms of what how many cycles will generate the arc. So in that situation, we don't call any difference between 60 or 50 hertz on that at all. It is splitting hairs between the actual instant energy rating of the fabrics, depending on what we use. And in the arc testing world, it's always at 50 hertz.
Perfect.
That
Thank
helps.
you. Thanks, Anthony. So next one from Benjamin. In your graph with base layers and jackets, is the reason the shirts and jackets are combined ATPV ratings because you conducted multi-layer arc testing? And is that testing accepted in the States?
Yes. Yep. So we test to both ASTM and the EN standards when we actually do the layer testing, and we do the layer testing to give an indication of what actual protection you would get. So bear in mind, I mentioned before, this layer testing isn't the garment itself, it's just the fabric. So it's a fabric sandwich with a very small air gap. In real life, you've always got a gap between your layers of garments. If you were wearing a t-shirt and you wore a jacket on top of it, there would always be a layer of air in between the t-shirt and the jacket. So generally speaking, when you have that layer result, you would generally get a lot higher artifact rating from that result, from that combination than we actually publish in our matrix.
Very good, thank you. So this is from N. Ross again. So ATPV and EBT are more accurate, but leave a 50% probability of where of the wearer getting burnt. Whilst the 12 cal Ealing garment is twice as heavy, it's providing a higher level of protection, even if no burn is not quite as guaranteed as it might appear.
Yeah, that's right. So at 12 cal Elim, you're still not guaranteed actually of getting a burn. So even though the label might say 12 cal Elim, you can go and stand in front of a 12 cal art flash, and you will walk away scot free, no burns, no redness, no soreness, etc. We can't guarantee that to you. So I can't guarantee that you'll wear a 12 cal Elim garment, have a 12 cal art flash, and come away not burnt for the reasons I discussed, with the fact that every single time we test a fabric, we get a different rating. So I might sell it as a 12 cal garment, but I can't guarantee that garment is 12 cal. It's 12 cal at the time the fabric was tested. But even if I tested another batch, it might not have been 12 cal Elim. It might be less, it might be 11 and a half, might be 11, for example. So the 50% probability is allowing for that error. So it's allowing for the undefiniteness of electricity. And it's also allowing for the indefiniteness of the actual fabric that's being produced. So fabric itself, as I said before, from the same batch, will get a different rating depending on, obviously, every single time you test it. You'll always get a different rating. So we can't guarantee anything. So the 50% probability is what we stick to or talk about in general as our general rule. And we talk about 50% probability of either break open or the thermal performance value, because the whole situation regarding the actual art that's generated, regarding people, are they working closer to or they're working further away? So in an elim, it's tested at 30 centimeters away from the actual arc itself. If, for example, that person is stood closer than 30 centimeters, they're going to be exposed to a higher arc flash rating. The further you are away from the torso of the arc, the lower the arc rating. So when we'll get an arc flash study done, and it says 12 cal, for example, for a particular bit of equipment, if you took a step back 2 inches, that arc flash rating would reduce from 12 cal down. If you took it a step closer, it goes from 12 cal, it might go to 16, 20, etc. So because we're dealing with people, we're not dealing with robots. We're dealing with different distances from equipment. We're dealing with fabric that's got different weights depending on productions and the actual makeup of the fabric. Sometimes a fabric might be slightly more dense than others, and the fact that the arc itself will take different shapes, forms, and pressure, and it also depends on the amount of molten metal that is ejected from the arc as well, because that also affects the performance of the fabric as well. So this is why elim, you're trying to define something. So if we dealt with robots and you're protecting a robot, you might be able to use elim, but we're protecting humans. So the 50% probability is the more practical solution than elim. But if you want to buy elim, we do still sell elim garments. Trust that helps, Nigel.
Thank you, Anthony. There's quite a few more questions here, so I'll rattle on. So
Yep.
this is from Telma in the chat. So can you tell if the garment composition contains PFASPER and polyfluoroalkyl substances?
You can't tell from the composition label. It's not something that's mandated to be put in a composition label. But what I would say is the majority of garments on the marketplace that have an EN 13034 chemical protection, particularly art flash garments, those garments, I would say more than likely to have PFAS or polyfluorocarbonates treatments on those. So yeah, I would always make sure that if you've got an EN 13034 label on your garment, that garment will be treated. There's only very few water-based finishes that protect against chemical protection. We no longer use any of those finishes ourselves in our garments due to the fact that we now have withdrawn EN 13034 from our certifications on our garments. If you've got chemicals that you're dealing with, wear a chemical garment. Don't wear an outflash garment. Or if you need to layer up with a chemical protective garment, not an outflash garment. And so yeah, definitely steer away from PFS. But it's not in the garment. It's not in the description of the garment. You would have to find out from the manufacturers if they do use those treatments.
Perfect,
Thelma?
thank you. Yep, thank you. So this is from Mark. Hi, Mike. So instead of wearing a 40 cal suit, I can layer up to get the same protection.
Correct. Yep. So 40 cal suit is designed so you could wear a 40 cal suit on top of your birthday suit. Okay. So it's designed, you could wear that against your skin. Obviously, when you wear it on top of other garments, you increase the protection. So 40 cal suits on top of normal outflash day wear clothing would give you a lot more protection than 40 cal. Obviously, apart from your face, because the face visor is obviously, you don't normally wear things over your face. You might have a balaclava, but your actual face, eyes, nose, etc. are normally exposed. But yeah, if you layer up, you can also achieve 40 cal layering up. But obviously, you just need to make sure that either the full body, gloves, hands, and then obviously a hood for the face is protected to the same value. Makes sense.
Great stuff. Let's keep moving. So this is from Michael. So with a 40 cal hood with a fan, do you think the fan should have a shut-off sensor to stop the fan from pulling in smoke, etc.?
Yeah, in an arc itself, obviously smoke is generated from the arc itself. You've probably seen videos online where there's smoke around. Some arcs will generate more smoke than others. We often show a few arc flash videos, and the smoke's pretty minimal. And particularly if you're outside, obviously that smoke's going away regardless. If you're inside, I wouldn't be too concerned about the actual smoke itself. I'd more be concerned about getting out of the vicinity. And generally speaking, any videos you see of an arc flash, most people are out of the vicinity before the smoke actually starts to develop. The smoke becomes a secondary aspect. So the first aspect of an arc flash is the explosion, coupled with the molten debris, which is ejected from the arc flash. And thirdly, it follows the smoke. And then obviously, if you've got monoclinic fabrics, they'll give an off gas. But that, again, the off gas is very limited in terms of how long it lasts for. But the off gas would be on the outside of the garment rather than the inside. I wouldn't get too hung up about the shut-off valve for smoke in the fans. I think more than anything, you would release the hood and get out the area rather than hang around in the area observing the scene. Makes sense.
Yes, I'm just conscious, Anthony. It's 4 o'clock and we've got
Yep.
one or two more
So
slides.
2 more slides. We'll jump onto those, and if we'll try and get back to everyone on any more questions that we haven't answered.
Yes, thank you.
So next one is introducing Daniel Henderson. So Dan will be joining us as the Global Head of Electrical Safety. He joins us this next month. So he'll lead our electrical safety advisory and consultancy business in support of our mission of saving lives. He's a fully qualified chartered electrical engineer, 10 years as an engineer in the Royal Navy, and another 10 years as an engineer in multiple industry work across the UK, Europe, and North America. So he has a wealth of knowledge. So he brings a deep knowledge of electrical systems, generation, transmission, distribution, LV and HV, but obviously a deep passion for electrical safety and a mission that we're on in saving lives. So it might be a bit of a strange move for some people to move from the electrical industry into a business that supplies PPE, but he's coming into supporting the advisory around electrical safety. It's a subject that matters a lot to him, and he's very deeply passionate about it. And the next slide then. So June 26th, 2025, again, the same time, we'll have our second power hour. So ArtFash PPE Uncovered, practical strategies, layering secrets, and field insights. So it'll be the next stage on from what we discussed today. You will, if you've logged in through the Zoom link, you will have a page showing with a questionnaire and a link to register for the next webinar. So please do register for the next webinar. We really thank you for your attendance today. It's been great seeing so many on the call. Thank you very much indeed. And as I say, any questions that you may have that we've not answered now or you want to enter into a further discussion about, by all means, drop us a line and we'll be in touch to discuss that further. And obviously, if you are struggling with understanding what to wear in what situations, by all means, give us a shout. We do that free of charge, and we're glad to help you out where we can in making sure that everyone stays safe and goes home safe. So with that, thank you very much for your attendance, and trust everyone has a good rest of the day, good evening,